Good evening, students.
Good evening,
Good
sir.
evening,
Good
sir.
evening,
Good
beta.
evening, sir.
Good evening, beta.
Good
Good evening, beta. So, uh, in atomic physics, first I want to discuss the syllabus of this. In atomic physics, first topic that I'm going to start with is Bohr model. Bohr atomic model. Bohr atomic model. Many times you are going to find out questions from the Bohr model. Okay? So many times you are going to find out a question based on directly formula based or on the basis of the reduced mass. So many, particularly in GATE exam, most of the time you will get a question from here. So this is a very important topic. Okay? So first topic is Bohr model. Okay? And after this, we are going to discuss angular momentum, orbital angular momentum, orbital angular momentum, momentum, magnetic moment or orbital magnetic moment, orbital magnetic moment, moment, spin, spin magnetic moment, spin magnetic moment, magnetic moment. Here, space quantization will be there. So these are the concepts which are actually used in describing various types of development in the atomic physics. So basically in atomic physics, first type of model that was given that was, but many models were there, but first significant model on the basis of one electron systems, they were described, their energy levels find out, that was the Bohr model. But there were many problems which were not sorted out by this model, where, or you can say, shortcomings were there. So to find out further insight into the atomic structure, okay, we have to study the magnetism process, okay, magnetization process that is taking place inside the atom. So spin magnetism, okay, orbital magnetism. So various type of magnetism type of processes or interaction, okay, na, that is going to take place. How they take place? They take place in the form of coupling, like spin orbit coupling. So how this spin couple orbit coupling is taking place, who is mediating in between this? So this is a magnetization process. So that magnetization process is responsible for the spin orbit coupling. And to understand that, we need these. ठीक है ना? We have to understand what is orbital angular momentum, what is orbital magnetic moment, spin magnetic moment, space quantization we are going to discuss. ठीक है, and then in last we will discuss spin orbit coupling. ठीक है, spin orbit coupling for one electron system, orbit coupling for one electron system, beta. One electron system. ठीक है. Here I will also discuss Stern-Garlick experiment also. When I will discuss spin, with spin, I'm also going to discuss the spin-Garlick experiment. ठीक है? So spin orbit coupling, ठीक है ना, or splitting you can say, ठीक है, spin orbit coupling or spin orbit splitting I am going to discuss here. After spin orbit splitting or coupling, we are going to discuss quantum mechanical or quantum mechanical relativistic effects. Third is quantum, ठीक है, quantum or relativistic corrections we are going to discuss. So actually there were many problems which were coming into the picture with spin orbit coupling. Even after introducing spin orbit coupling, you are not able to explain various aspects. So next was, so first type of correction was introduced, that is called as quantum relativistic corrections. Okay. Then after this I am going to discuss fine structure. Fine structure. After fine structure, we will further move to discuss Dirac equation. Dirac equation. And then lamp shift in lamp shift. So basically up to this point we are discussing one electron system. In one electron system, how spin and orbit they are coupling, and due to that coupling how splitting is taking place. So sometimes it is also called as spin orbit splitting. Okay, so after this there were some problems. So to remove those problems, these relativistic corrections were introduced, and by combining this spin orbit coupling or interaction and this relativistic correction, basically fine structure was developed. But still it was not answering all the questions. Some problems were there. Then Dirac equation was introduced, and later on further modification was done and lamp shift was introduced. So in this way we are going to discuss. After this, after this I'm going to discuss LS coupling and JJ coupling. Now you are actually up to this point you were considering only one electron system, but if you are having many electron system, then LS coupling. How to find out the spectral term if you are having multi-electron system, many electron system are there. So for that purpose, ठीक है ना, for that purpose, LS coupling and JJ coupling is used. So with the help of LS coupling and JJ coupling, we will understand how different spectral terms comes into the picture in for many electron system. If you are having many electron system, then there are many spectral term, and existence of these spectral terms can be explained in the form of LS coupling and JJ coupling beta. So here we are going to discuss many cases for LS and JJ coupling. Okay, selection rules will be there in each and every aspect of these couplings I am going to discuss. After that, we will discuss G-man effect. If you are placing an atom in an external magnetic field, then how the splitting of energy levels will take place. So in the presence of weak external magnetic field, how splitting takes place. ठीक है ना, that is explained, ठीक है, in terms of G-man effect. So two type of G-man effect we will discuss. One is normal G-man effect. Normal G-man effect, normal G-man, and anomalous G-man effect. Anomalous G-man effect. In case of G-man effect, we are studying the splitting of different levels when external magnetic field is weak. When external magnetic field is weak, now what will happen if this external magnetic field it becomes strong? Then this it will convert into Paschen-Beck effect. Paschen-Beck effect. ठीक है. So basically here, if you are placing or the atom is interacting with a weak magnetic external magnetic field, then normal Zeeman effect or anomalous Zeeman effect comes into the picture. But if this external magnetic field becomes strong, ठीक है ना, if atom is placed in a strong magnetic field, external field, strong external field, then Paschen back effect will come into the picture. And last is hyperfine structure. Beta. Last topic is hyperfine hyperfine structures which are observed experimentally, and they can be explained only if you are considering the spin of the nuclei. Up to this point, you are not considering the spin of nuclei, but you will find out hyperfine structure that can only be explained if you are including the effect of nuclear spin into your atomic model, whatever model you have developed up to this point. So in this way, the development of atomic physics, ठीक है ना, takes place. So from Bohr model, first model, ठीक है, which was able to explain single electron systems, ठीक है ना, and after that we move to our different type of coupling, spin orbit coupling particularly, ठीक है. So to understand the spin orbit coupling, what you need orbital angle. You should know what is the meaning of orbital angular momentum, what is the meaning of spin angular momentum, what are the magnetic moments, and when these magnetic moments they are placed in an external magnetic field, how they are going to interact with this. So all these aspects you are going to understand here, and then I will introduce spin orbit coupling. But this spin orbit coupling is for one electron system, and a single level, P level, D level, F level, they are going to split into two levels.
एक्सक्यूज
Then,
मी सर.
yes, beta, please.
सर ये थर्ड वाला थोड़ा सा रब हो गया है, रेज हो गया.
Okay, beta. This will be quantum, then quantum relativistic, and this is fine structure. This is fine structure. Now, spin orbit coupling is okay, but various anomalies were there. Those to understand those anomalies, to remove those anomalies, some type of corrections were needed. So first such correction was relativistic correction. And when this relativistic correction, it was coupled with this spin orbit coupling, together they are combined, then fine structure, ठीक है ना, fine structure can be explained. After fine structure, still there was some problem, ठीक है ना. For example, in H alpha line, there were many components which cannot be explained. So for that purpose, Drake equation was introduced. But still, Drake equation was not able to give the exact number of components which are observed in H alpha line. So for that purpose, later on, Lamb shift was introduced. Now, this was okay with one electron system, but if you are having many electron system, then how will you find out different spectral terms? Those spectral terms one can find out by two techniques. For some atoms, ठीक है ना, you are going to use LS coupling. For some other atoms, you are going to use JJ coupling. What is the criteria when you are going to use LS coupling, when you are going to use JJ coupling? For that purpose, we are going to understand all these things. Now, if external magnetic field is next thing is, if external magnetic field is there, ठीक है ना, external field is present, then what will happen? Then this normal Zeeman effect takes place. If you further increase this external magnetic field, then this Paschen-Beck effect is there. But still, a very hyperfine type of spectra was observed, observed, and that hyperfine structure can only be explained if you are considering the spin, if you are including spin of the nuclei into your consideration. So I'm going to discuss all these topics in atomic physics. ठीक
Sir,
है?
which book to follow? Yeah.
Uh, देखो, particularly if you want to use some Indian book, which that is Rajkumar, Atomic Physics by Rajkumar. Atomic and Molecular Spectra. Name of the book is Atomic and Molecular Spectra. Molecular Spectra by Rajkumar. I'm suggesting this book. This is a good book. ठीक है, and many of the students follow this book in his PG program. Second book that is a very good book, that is Atomic Spectra. Atomic Spectra by White. By White. You are going to find out its online copy. ठीक है ना? Soft copy you can find out for this book. ठीक है? Hard copy I don't think now that is there. ठीक है? But this is very very good book. One of the best book for atomic spectra. ठीक है? So this book is there. So this is the syllabus. And if you are if you are considering the weightage of this topic, so from atomic physics you are going to get 5 marks. ठीक है ना? 5 marks. From this section, you will get 3 questions. This complete section is consisting of 3 parts. One is atomic physics, second is molecular spectra, and third one is lasers. So 3 questions you are going to find out from this section. One question from atomic physics, second is from molecular spectra, and third from the lasers. And third from the lasers. So from here, you will get 5 marks question in part C of your CSIR net exam. ठीक है? As far as JAM students are concerned, they have to study only this one, only one first chapter. For IIT JAM students, your syllabus consists of only this one. For IIT JAM, IIT JAM student. ठीक है? Only first chapter is required. This Bohr model is required. This is a part of modern physics. ठीक है? This is a part of the section that is modern physics. So for this, ठीक है ना? For IIT JAM students, book is concept of modern physics. You don't need to purchase these books or go through these books. For you, book is concept of modern physics. Concepts of modern physics by Arthur Beezer. Arthur Beezer. ठीक है? For IIT JAM students, only first chapter is in their syllabus. For CSIR NET, GATE examination, JEST examination, this complete syllabus is there. ठीक है ना? तो ये complete syllabus है for from the atomic physics. From atomic physics in GATE examination, you will find out more weightage from this section. ठीक है? As
सर
compared to
गेट
yes.
एग्जाम में कितना वेटेज होगा?
In GATE examination, at least you will find out 2 or 3 questions from this section. ठीक है? At least 2 questions
Sir,
from. Yes,
So
beta,
how
please.
many marks of how many marks?
4 5 marks, 5 marks. But paper is of 100. Here paper is of 200. Yes, beta, please.
sir, I am an BSc Physics student. So I am preparing for a GATE and just examination. So
Okay.
what are chapter I am studying?
For GATE examination, you have to complete this syllabus. Complete all the chapters you have to study for GATE examination. ठीक है? For GATE examination, for CSIR NET examination, जेस्ट में क्वेश्चंस कम आते हैं. ठीक है? जेस्ट एग्जामिनेशन और टीएफआर. ठीक है? दिस कंप्लीट सिलेबस इज देयर फॉर आईआईटी जैम स्टूडेंट्स ओनली फर्स्ट चैप्टर. ठीक है? फॉर आईआईटी
Sir,
जैम यस बेटा प्लीज.
so what about the integrated PhD entrance of TIFR?
For TIFR, if you are a BSc students, graduate students, ठीक है, then only first chapter. If you are appearing for PhD after MSc, then this complete syllabus you have to do. You cannot complete this syllabus just for one exam. This is a lengthy syllabus. So please go through. If you are appearing for integrated PhD program, just go through this first chapter. ठीक है? If you want to study, you can go up to this. ठीक है ना? Maximum second of first and second only. ठीक है? Maximum this, not more than this. ठीक है? If you are having any another query or question, ठीक है, please ask.
Thank you, sir.
Welcome. Now, atomic spectra. Atomic spectra. First, write the definition, then I will explain you. Okay, please. When an atomic gas or vapor, please write, when an atomic gas or vapor is excited, is excited, is excited, when atomic gas, ठीक है, when an atomic gas or vapor is excited by any means, by any means, by any means, any means, then after some time, then after some time, these atoms in the excited state, then atoms in the excited states jumps to lower excited states, jumps to lower excited states, lower excited state, and emit radiation, and emit radiation, jumps to lower excited state and emit radiation, and emit radiation, full stop. This emitted radiation, this emitted radiation, this emitted radiation consists of discrete wavelengths. This emitted radiation consists of discrete wavelengths, full stop. This family of discrete wavelengths, this family of discrete wavelengths is called the spectra, is called the spectra or spectrum, atomic spectra or atomic spectrum or atomic spectrum of that gas, atomic spectrum of that gas, full stop. These individual wavelengths are called spectral lines. These individual wavelengths are called spectral lines. Spectral lines. So what I'm saying, when you are having a gas, okay, like hydrogen gas, yes, beta, please.
Sir, can you repeat the last line? These
Okay.
individual.
These individual wavelengths are called spectral lines. These individual wavelengths are called spectral lines. Okay. So simplest type of spectra, if you want to observe, that is the hydrogen spectra. If you are having a atomic gas of hydrogen and you excite this, ठीक है ना, by any means, ठीक है, you are passing electric current or doing some type of discharge, ठीक है, if these atoms moves to excited state, then after some time, because they are in the excited state, they are going to jump to lower excited state. How they can jump to the lower excited state? Basically by emitting energy in the form of a photon. If it is here, then it can jump from here to here, here to here, from excited state to lower excited state or the ground state by emitting a photon, by emitting a photon, h nu. So basically when this excited gas, ठीक है,
सर
de-excites, yes beta please.
सर ये जो रेडिएशन होगा ये हमेशा ईएमओ भी होगा?
रेडिएशन बेटा ईएम वेव होगा, फोटॉन्स होंगे, ठीक है, इलेक्ट्रोमैग्नेटिक रेडिएशन, This radiation will be electromagnetic radiation. So when atoms moves from excited state to the lower excited state, it will emit photons. So basically these photons together they are called as emitted radiation. So when excited gas, ठीक है ना, goes to it de-excites, then a radiation will be emitted. If one observes this radiation with the help of a spectrometer, then you will find out this radiation is consisting of many wavelengths. These wavelengths, suppose there may be many number of wavelengths, and these individual wavelengths you call them a spectral line. And this combined spectra, ठीक है ना, combined family of this wavelength that is exhibited by this emitted radiation, that is called as atomic spectra. That is called as atomic spectra. Now, simplest type of atomic spectra is for hydrogen gas. For hydrogen gas. ठीक है, हाइड्रोजन गैस बेटा, ठीक है. तो simplest type of spectra is exhibited by hydrogen gas, and this consists of this hydrogen gas spectra, you can say it consists of many families of lines. Particularly 5 families of lines will be there. So this hydrogen gas spectra, it is made up of 5 families, ठीक है, of spectral lines. So they are called as series. ठीक है? So it is made up of 5 families of spectral lines. Families of spectral lines. Okay. And these families, what you call as? You call them series. Series. Okay. So this hydrogen gas spectra, it is made up of, you can say, 5 series. 5 series. So you can write simplest type of spectra. Simplest type of spectra is hydrogen gas spectra, which consists of following 5 series.
Can you repeat again, sir?
Yes, beta, please. Simplest type of spectra. Simplest type of spectra is hydrogen gas spectra. Simplest type of spectra is hydrogen gas spectra, which consists of 5 series. Which consists of 5 series. Number 1, Lyman series. Lyman series. ठीक है. What is the meaning of Lyman series? ठीक है. Lyman series, you can write here that this series, these lines which are the lines of this series, they fall in ultraviolet region, UV, UV visible UV region, ultraviolet region of electromagnetic spectrum. So lines of this Lyman series falls in ultraviolet region of electromagnetic spectrum. Now, what is the meaning of this Lyman series? So if you consider the hydrogen atom, this will be n equal to 1, then n equal to 2. I am not changing spacings just to explain you. 2, n equal to 3 is here, so don't go by spacing. N equal to 3, then there will be n equal to 4, n equal to 5, like this. These are different energy levels that is exhibited by the hydrogen atom. ठीक है, कितना एनर्जी होता है, what will be energy in 12th class you study, that is En equal to minus
minus 13.6
13.6 electron volt.
by
upon
n
n,
square.
n square, and this will be in electron volt. Very correct, beta. So these are. So basically, how the lines of this series are created? They are created if an electron, ठीक है ना? If an electron is in n equal to 2 and it jumps to this. So during excitation, what is happening to hydrogen atom? Hydrogen atom is consisting of one electron. And when it is getting energy from the outside, this electron, single electron, originally which is in the ground state n equal to 1, it can move to 2, 3, 4, 5. So in the excited gas, basically this electron can be anywhere. So how this atom is going to de-excite? When this electron is going to jump from n equal to 2 to n equal to 1, or if it is in n equal to 3, then from n equal to 3 to n equal to 1. From here, n equal to 4 to n equal to 1. So during de-excitation, if if electron is jumping from a higher state to n equal to 1 state, means these lines, they are starting or they are terminating at n equal to 1. ठीक है, they are terminating at n equal to 1. So here, in case of Lyman series, ठीक है, in case of Lyman series, electron jumps from a high energy level to n equal to 1. So in this transition, ठीक है, transition कैसे होगा? This will be ni to nf. And what will be nf? Nf will be 1. So in this transition, electron jumps from a higher state to n equal to 1 state. ठीक है, from the higher state. So what can be this ni? Ni कितना हो सकता है? It will be greater than 1. So
Greater
this
than
may
one.
be 2, 3,
2, 3, 4,
4,
5.
5, like this, like this. ठीक है. If you want to write its wavelength will be 1 by lambda, that is given by 1 by lambda. And here this is called as Rydberg constant. You write here R infinity in journal. And this will be this will be 1 upon 1 square minus 1 upon ni square. This will be. So basically, here transition is taking place from a higher state to nf equal to 1 state. ठीक है? तो final state is for the electron is n equal to 1 state. So all the lines, ठीक है, all the spectral lines which are corresponding to transitions where final state of the electron is n equal to 1, where final state of the electron is n equal to 1. So that type of line. So in all these transitions, try to understand, in all these transitions, photons are going to be emitted. Photons are going to be emitted. And because energy gap is different, here energy gap is different, here energy gap is different, here energy gap is different. So because these energy gaps are different, they are going to have different frequencies. These photons are going to have different energies. You can write like h nu 1, h nu 2, h nu 3, h nu 4. So basically this family of lines which you call as Lyman series, it consists of many lines or many wavelengths, many frequencies. So that's why they are having many wavelengths or many frequencies, because these transitions are corresponding to different energy gaps. So in every transition, a photon of different energy is emitted. Its frequency will be different, its wavelength will be different. That's why this family is going to have many lines. ठीक है ना? This family is going to have many lines. बहुत सारी lines से मिलके बना है. Can you tell me what will be the lambda minimum here for this series? What will be the lambda minimum? Lambda minimum will be, lambda minimum you want to find out, so energy gap should be maximum. So in this series, Ni to Nf equal to 1, you want to find out the wavelength that is minimum. Minimum wavelength will be corresponding to maximum energy, because delta E कितना होता है? What is delta E? That will be equal to hc upon lambda or h nu. ठीक है ना? It is h nu. We are saying the gap of energy, ठीक है, corresponding to this energy gap, a photon will be emitted. This photon will carry a energy that will be equal to this energy gap. So this is delta E will be equal to h nu. How much is nu? Nu is c by lambda. So this will be hc by lambda. hc by lambda. ठीक है? So delta E is equal to hc upon lambda and equal to h nu. It is like this. Okay? This will be h nu. So for every gap, there is a different frequency, different wavelength will be there. So now you want to find out the minimum wavelength. So for minimum wavelength, look here. If you want lambda minimum here, this delta E it should be maximum. So lambda minimum will be corresponding to maximum energy gap. So maximum energy gap will be when n becomes
Infinity,
infinity,
sir.
it
Infinity.
will become infinity. So lambda minimum will be corresponding to when ni initial state is infinity. So that will be infinity. So this will be r infinity divided by this will be 1 square. This will be 1 square. Sorry, ये उल्टा लिख दिया मैंने, just 1 second. This will be, if you want to find out 1 upon lambda minimum, then this will be 1 square, or you can say lambda minimum, that will be
1
equal
upon
to
R
1,
infinity.
1 square upon r infinity. ठीक है, 1 upon r infinity. Is it clear? अब इसका वैल्यू कितना होता है? Can anyone tell me what will be the value?
911 angstrom.
बिल्कुल 1 upon r कितना होता है? You can remember this. Always this will help you. ठीक है, 917.4 angstrom. This will help you a lot in atomic physics in solving numericals. You can remember this number. 1 upon r infinity will be equal to 917.4. So basically, Lyman series is a family of lines, spectral lines, which are originated when transition of electron is from higher state to n equal to 1 state. So these spectral lines are coming into the picture, and this series is called as Lyman series. Lyman series. Second such series is Balmer series, ठीक है, which is observed in visible region or near UV region. Second series is Balmer series. Balmer series.
Sir,
Yes, beta.
sir, can you show me the first slide?
Just 1 second, beta, please.
Sir, the first slide.
First one, okay. This is the first one. I will show you later on. In the last, I will show you all the slides. So please अभी आगे चलते हैं. Otherwise, so next series is Balmer series. This series was the first series that was observed by the people or the scientists who were working in this field. ठीक है? This was the first series that was observed. Why this was first observed? Because lines of this, spectral lines of this, they are falling in the visible region. Visible region of electromagnetic spectrum. So many lines of the Balmer series, they were falling in the visible region or sometimes in near UV region, or you can write some lines in near UV region. UV region. Particularly in visible region, because these Balmer series, they are observed in the visible region, so automatically they were the first which were observed. And how these lines are created? These lines are created corresponding to this transition. Ni is the excited state, and what is the final state for the electron? That will be the NF. NF will be 2.
Two.
So these lines, which are a part of this Balmer series, they are coming into the picture when transition of electron takes place from the higher state to the n equal to 2 state. So what will be the higher states here? That will be Ni
Four,
equal to
5.
greater than 2 bit. Eh? So 3, 4, 5, like this, so on, so on. What will the formula for this? This will be 1 by lambda. This will be R infinity. R infinity. Okay? And this will be 1 upon 2 square. How this formula is coming? ठीक है ना, आई एम गोइंग टू डिस्कस, वी विल ड्राइव दिस फॉर्मूला 1/2 स्क्वायर माइनस 1 अपॉन ni स्क्वायर बेटा, ni square. This will be the formula. This is called as Rydberg constant. ठीक है, दिस इज कॉल्ड एज Rydberg constant. और ये इन्फिनिटी क्यों लिखते हो, वाई यू आर राइटिंग हियर इन्फिनिटी, व्हाट दिस इन्फिनिटी इज सिग्निफाइंग हियर, ये जो इन्फिनिटी है ये क्या सिग्निफाई कर रहा है बेटा, बोलो। देखो, आर इन्फिनिटी कितना होता है, आर इन्फिनिटी इज 1.09 इंटू 10⁻⁷
7.
ठीक, 7 बेटा। और ये जो इन्फिनिटी है ना, व्हाट इट इज describing, it is saying here when you are writing R infinity, from infinity you are saying that nuclei nuclei or nucleus is infinitely heavy, is infinitely heavy. Just one second. Infinitely heavy heavy as compared to electrons, as compared to electron, ठीक है। Or you can say from here, ठीक है, what is the meaning of this, you are saying that in hydrogen atom you are having a proton here inside the nuclei, and suppose electron is revolving around it. I have not discussed this, but I'm just telling you. So here you are saying this nuclei is infinitely heavy with respect to this electron. Then you are going to write this infinity. R infinity, ठीक है ना? R infinity is the value of Rydberg constant only when you are going to you are going to consider you are going to consider that this nuclei is infinitely heavy as compared to this electron. Means you are saying mass of the electron is like this as compared to the mass of the nuclei, as compare. So what you are saying, actually you are saying that this is at rest, this nuclei, because it is infinitely heavy. So you are saying this nuclei is at rest. So by considering this condition, you are assuming that nuclei, ठीक है ना, nuclei is at rest. Nuclei is at rest, and only electron is revolving around the nucleus, and electron is revolving around the nucleus, around the nucleus, ठीक है। इसका यूनिट क्या होता है, दैट इज मीटर इनवर्स, यूनिट ऑफ दिस इज मीटर इनवर्स, ठीक है। सो this is the value of Rydberg constant when you are saying my nuclei is at rest for that atom and only electron is revolving. But in reality, that is okay, that mass of the nuclei is very, very high as compared to the mass of the electron, but still, it is having finite mass. And if you consider the finite mass later on, when you will consider, if you consider the finite mass of the nuclei, if one considers the finite mass of the finite mass of the nuclei, then both electron as well as nuclei, as well as nuclei, nuclei will rotate, किसके रोटेट करेंगे, अराउंड center of mass, around center of mass. Then how you solve this problem, actually here in that
Two
case
body problem for one body.
this will be two body problem. Very correct, beta. So in that case, both the bodies are moving and they are revolving, not rotating. Actually, the nuclei will revolve, not rotate, revolve. Okay, revolve around the center of mass. Okay, it will be like this. Now both are moving. So now you are having a two body problem. So in that case, you will convert this two body problem into a single body problem, into one body problem by introducing the concept of reduced mass. In that case, you will use the reduced mass concept. So here R infinity, when you are writing R infinity, this infinity is signifying that this is the value of Rydberg constant. When we are assuming that nuclei is at rest, it is infinitely heavy as compared to the electron beta, as compared to the electron. Now come to the Balmer series beta. So Balmer series, when you are going to get lambda minimum in case of Balmer series, again this lambda minimum will be corresponding to Ni equal to
Ni is
infinity,
equal to infinity.
so that energy gap will become again maximum. So this will be lambda minimum कितना होगा बेटा ये? That will be 2 square if you find out 2 square upon R infinity. Substitute in this formula, please substitute in this formula infinity, so this will become 0. So what will be lambda? Lambda will be 2 square upon R infinity. 2 square upon R infinity. So this will be, and this series will be like this. All the lines, they are going to terminate here. This is n equal to 2, n equal to 1. So higher levels are 3, 4, 5 like this. This is n equal to 3, n equal to 4, n equal to 5. So 3 to 2, this series, beta, this series in which electron is jumping from higher excited state to n equal to 2. Means this transition is from higher state to n equal to 2 state. So this is Balmer series. इस series को क्या बोलते हैं बेटा? This is called as Balmer series. Balmer series. So this is the second one. ठीक है? This is the second one. Third is क्या होता है बेटा? Paschen series.
Paschen.
Lyman, Balmer, and third is Paschen series. कहाँ होता है बेटा Paschen series? Where it is find out infrared region. Third is Paschen series. Third is Paschen series, and it is find out where? In IR region, you can say. IR region. And this series is corresponding to the electron transition from Ni higher states to Nf equal to 3. So basically this series consists of the spectral lines which are corresponding to the electron transitions from higher energy states to n equal to 3 states. So they are terminating these transitions. Basically they are going to give rise to the Paschen series. So this series, and this is called as Paschen series pattern. Paschen series, ठीक है? And here formula is 1 by lambda, and this will be R infinity. This will be 1 by 3 square minus 1 upon Ni square. Lambda minimum, it will be same. Lambda minimum will be 3 square upon R infinity. Upon R infinity, ठीक है? Lambda minimum will be 3 square upon R infinity. One more thing, okay, that I have missed here. In case of this लाइमन सीरीज, ठीक है। लाइमन सीरीज के केस में basically they have given some names to this. For example, this first line I'm writing here, n equal to 2 to n equal to 1 line, that is called as L alpha line. They have given this a name that is called as L alpha. So this line, this spectral line corresponding to this electron transition from n equal to 2 to n equal to 1, this is called as L alpha line. N equal to 3 to n equal to 1, that is called as L beta. N equal to 4 to n equal to 1, this will be L gamma line. So these three names, ठीक है, these particular three names, L alpha, L beta, L gamma, these names were given for these spectral lines. So you have to remember, if someone is saying L alpha or L beta or L gamma, ठीक है ना, you should be very clear in your mind what is the meaning of L alpha, what is the meaning of L beta, what is the meaning of L gamma, ठीक है. Now, very similar to this, please note it down. Note it down, please. Now, it's very similar to this. In case of Balmer series, ठीक है ना, Balmer series here, in this Balmer series, this n equal to 3 to n equal to 2 transition line, ठीक है, this is called as H alpha line. N equal to 4 to n equal to 2 line, that is called as H beta line. And n equal to 5 to n equal to 2, that is H gamma line. So these 6 names you have to remember. So in many times you will find out H alpha line, H beta line. So you have to remember this aspect. So they are sometimes they will not mention from which level to which level transition is taking place. Just they will ask about this H alpha line or H beta, yeah, L beta or L alpha. Then you should be very clear. So heard that I was discussing, this is Partian series. So Partian series, this is find out in IR region of electromagnetic spectrum. ठीक है? Lyman, Balmer, Partian, then bracket. Fourth is bracket series. They are very similar. I'm just writing formulas. Bracket series. ठीक है? Where they're in which region they are find out?
Far
They are
infrared.
far infrared in general. Far IR. And these transitions, they are corresponding to Ni higher states to this will be NF equal to 4. Formula is 1 by lambda. That will be R infinity 1 upon 4 square minus 1 upon this Ni square. What will be lambda minimum? That will be 4 square upon R infinity. ठीक है. Similarly, last is Fund series. And it is also find out in far IR region, far infrared region, and this is corresponding to the electron transition from higher states to NF equal to 5 state. Final state is 5. So higher state means greater than 5. So Ni will be 6, 7, 8 like this. Okay, this is called as Fund series. Here lambda minimum, that will be 5 square upon R infinity. ठीक है, 5 square upon R infinity. So these are the 5 series which is exhibited by the hydrogen atom. So ठीक है, these five series, ठीक है ना, they are these five series, they are making the complete spectrum. Individually they are series, and these series are, they are made up of a spectral line. So spectral line is the smallest unit, and this complete spectrum is divided into five parts. So that's why this is called as series, and all the five series together they are called as spectrum. ठीक है, hydrogen gas spectrum. Now next question is how to explain this series. Yes beta, please.
सर लास्ट स्लाइड दिखाना प्लीज.
Now next
Sir, I
question
have a
is,
doubt.
yes beta, please बोलिए.
Sir, actually, how many spectral lines in hydrogen spectrum? Only 5 lines or more than 5 lines?
There are many lines. They are not five lines, they are five series. One series is consisting of many lines, many spectral lines. For example, here, ठीक है ना, it will move like this. Many spectral lines, they are creating this, they are a part of this Lyman series. Paschen series, Brackett series, Fund series, all the five series, they are made up of many spectral lines. So they are not representing five lines. They are not representing five lines. They are representing five families of line. ठीक है, five families of line. ठीक है, because
Sir,
why you are getting these separately, the reason is they are falling in different regions of electromagnetic spectrum. They are all falling in different regions of spectrums. So that's why they are saying them series. Yes beta, please.
sir, if n is equal to 6, then it can be seen higher region.
N equal to 6 means,
Sir, if P1 series n is equal to 5.
okay, infinite series. Okay,
So
just one.
what about other series? If n is equal to 6, 7, 8, 9.
No, actually, they are not observed. That they are not observed. Why they are not observed? ठीक है, तो in general these five lines are observed. सोच के देखना बेटा, ठीक है ना, they
So
are not.
why they are not observed?
बोलो बेटा, आप बताओ why. ठीक है, देखो क्या होगा अगर आप इसकी वैल्यू जो ये है 1/6 स्क्वायर करोगे, ठीक है, और फिर वो जो गैप कैलकुलेट करोगे ना, यू आर नॉट गोइंग टू फाइंड आउट एनी चेंज. ठीक है ना, हाउ शुड आई से दैट यू आर गेटिंग these five lines. और कहाँ गए, जैसे फॉर एग्जाम्पल हियर ये लाइमन सीरीज है. फर्स्ट लाइन, दिस इज ऑब्जर्व when all the transitions which are terminating here at n equal to 1. Second line, where at n equal to 2, there. At n equal to 3, n equal to 4, n equal to 5. ठीक है, after this they have not observed these lines. Why they have not observed these lines? So इसी का आपको आंसर ढूंढना है. So that's why these models are developed. ठीक है, ठीक है, that's why. And what will be the wavelength of these lines? Not only this कि you are getting only five series, ठीक है, but also this, what are the wavelengths of these lines? How you are getting these? How you are getting these expressions? ठीक है, you have to go, you have to find out this one. So all these things you have to find out. So for this, what do you need? You need atomic models to find out the answer of all these questions what he's saying. And not only that, but also this, for example, another problems were also there. For example, suppose you are using this L alpha line or H alpha line or H beta line. Okay, you are if you look at these lines, if you resolve these lines through a spectrometer whose resolving power is quite good, then you will find out that these H alpha lines, they are also made up of many lines. They are also made up of many lines. So from where, how you are going to explain these lines which are which are inside this H alpha line, and when you are resolving H alpha, H beta, these lines, they themselves are made up of many lines. ठीक है, so what is the reason behind all this? You have to find out these answers. ठीक है, तो आपको यही answers ढूंढने हैं. And for these answers, this complete atomic physics it was developed. So development of the atomic physics in such a way that first they find out, okay, experimentally they find out 5 series. So first question was why this type of discrete lines they are observing, why 5 series are observed, why not more than 5 series were observed. And further on the further development of a spectrometer, these lines are further find out that they are made up of many lines. Okay, so some answers were there, doublets were formed. Okay, when you place the atom in a magnetic field, many single spectral line they are going to split into many lines. So these were so many questions for the answer of which we need different models. We need some type of, just 1 second यार कुछ कीड़ा था. You need a model. So it was very difficult. Many people tried those models, but they were not able to find out the correct answer. So this was a very systematic process. Whatever I have written as your syllabus, that is actually the development of atomic physics. Development of atomic. In this way, this atomic physics was developed. So first model, I will answer your question. Don't worry, beta. Okay. I will answer all the questions which you are going to ask. So first such model that was given by Bohr. It answers many questions, not all the questions, but many of the answers were provided by Bohr's model. Bohr's model, why it is so important? Why this model is so important? There are two reasons. First time this model was able to give us a formula, ठीक है ना, with the help of which you can explain the spectra of single electron system. ठीक है, all the wavelengths of the single electron system spectras, systems or atoms, ठीक है ना, which are having single electrons, like it may be hydrogen atom or helium ion, lithium ion, their spectra can be explained with the help of this model. So this was a quite great thing at that time. Not only that time, still. So first, this model was able to explain the spectra of single electron systems. Okay? So whenever they are saying single electron system, it means they're talking about this single electron system. So this is applicable first thing for single electron systems. Hello, beta. किसी का mic on है. The single electron systems. So we are going to start with single electron system. This was one of the importance of this. These spectras, they were explained. Second was, this was not a very simple model. This model was semi-classical model. Okay, this Bohr model was
Sir, single electron means, sir, outside the cell
outside
is
nuclei.
yes,
Outside the nuclei, only
yes,
one
one.
electron is there. ठीक है, inside the nuclei, ठीक है, inside the nuclei there may be many particles, ठीक है, for example lithium, ठीक है, but outside the nuclei, lithium ion, you are having only one electrons, ठीक है, others are removed. In case of helium ion, one electron is removed. Here, two electrons are removed. Now, this is not a simple model. This is semi-classical model. Why it is so important and why it was extraordinary? Question is why this is extraordinary. It is still applicable. It is not failed. For single electron system, it is still applicable. Semi-classical model. Semi-classical model.
So what is the meaning of semi-classical model?
Yeah, I am answering better. So semi-classical model means some of the aspect he borrowed from classical mechanics. ठीक है ना? From classical mechanics, he borrowed some of the concept, and other concept at the same time he borrowed from quantum mechanics. So this is a amalgamated model of classical ideas, plus he amalgamated these classical ideas with quantum ideas. ठीक है? So this model is, that's why this is called as semi-classical, not exactly classical, because in this model he is not only using classical ideas, but at the same time, many of the classical ideas like quantization of angular momentum, quantization of energy, these concepts were used by him. So here he was using, at the same time he is using classical model, and at the same time he was using quantum aspects. Okay? So that was a big thing. How can a person imagine these two things together? So that's why he was a genius. Okay? In many fields he worked. Okay? His name is not like Einstein or Newton, but he did he provided many theory. He developed many theories. In various fields you are going to find out his contribution. Okay? Now, what is Bohr model? You please write. Bohr model is a semi-classical model. Bohr model is a semi-classical model model which consists of three postulates. Which consists of three postulates. Postulates. Okay, number one. Please write number one, which consists of three postulates. Number one, please write. The classical equation of motion. The classical equation of motion are valid for electrons in atom. Classical equation of motion are valid for electrons in atom, comma. However, only certain discrete energy levels. However, only certain discrete energy levels with energies En लिख लो, with energies En are allowed. With energies like this En are allowed. ठीक है? These are called energy levels of the atom. These are called energy levels of the atom. So please look at the first statement. He's saying that, if you look at, he's saying F equal to ma. So he's saying that this equation you can write like this: F, okay, this force will be responsible for the acceleration. This equation F equal to ma, this equation is
Sir,
valid.
these are called the energy levels of
Yes, beta, please.
last line.
Last line matlab? Okay.
These energy levels are called.
These are these are called energy levels of the atom. These are called energy levels of the atom. These are called energy levels of the atom.
Because
So what I'm
Sir,
saying?
sir, done.
Yes, beta.
So, what is the meaning of postulate in physics?
What is the meaning of
Postulate.
postulates? Okay, I'm coming to that. Okay, postulates. I'm telling you, beta. So first look at this. F equal to ma. ठीक है? What it is saying that you are applying the force, acceleration is produced. So this is a classical equation of motion. So it is still valid. In case of how this is valid, basically electrons in this model, he will say that electrons are revolving in the circular orbit around the nuclei. So for this circular, if electron is undergoing circular orbit, then what should be needed? You need centripetal force. So mv square upon r. So this is mass, this is acceleration. So for the circular motion, centripetal acceleration will be needed. So m into v square upon r, this is ma actually. And this will be how much? How much? That will be given by the
Electrostatic
electrostatic
force.
attraction between the electron and the nuclei. So this will be k times, you can write. Yeah, 1 upon 4 pi epsilon naught. Okay. On electron, this is a charge on the electron. And this is Z, not plus, no need of plus. This will be ZD. ZD upon, and this will be R square. Why I'm not writing? Because the reason is very simple. Why I'm not writing minus? Because I have already considered that as electron is here. On this electron, where what will the direction of the centripetal force? That will be this Fc inward. This is, you can say, minus r cap. Similarly, in which direction that force is going to act. So both are acting in this direction. So the source of this Fc, who is the source of this Fc? This electrostatic interaction. So that's why minus sign is not there, because I have already considered that this centripetal force is acting inward. That's why I have not placed here minus sign. Okay. So this equation is valid here. I'm coming to your postulate beta. Okay. So basically, this equation is a classical equation and it is valid. But at the same time, what is saying that these electrons, they can exist only in certain energy levels. So that is discretization of energy or quantization of energy. Okay. On one side, he is saying that classical equation of motion is valid. And on the second, on the other side, he's saying that only certain discrete orbits, orbits which are defined, which are basically which are defined by energy. Okay? So they can have only certain discrete energy levels. So that is a quantum idea. So in one postulate, in this postulate, both things, both aspects he is using. That's why this is called a semi-classical. On one side, he is using classical idea. On the other side, he is using quantum idea.
सर इस पे सोरेंजर इक्वेशन अप्लाई हो सकता है
किस में बेटा?
इस इलेक्ट्रॉन पे?
बिल्कुल. जब आप हाइड्रोजन एटम प्रॉब्लम सॉल्व करते हो इन क्वांटम मैकेनिक्स, यू आर यूजिंग श्रोडिंगर इक्वेशन. ठीक है ना? यू आर सॉल्व इन क्वांटम मैकेनिक्स, देयर विल बी अ कंप्लीट चैप्टर फॉर दिस हाइड्रोजन एटम प्रॉब्लम. ठीक है? एंड यू आर यूजिंग श्रोडिंगर इक्वेशन टू फाइंड आउट दीज एनर्जी लेवल्स. तो आपको सारे एनर्जी लेवल्स मिल जाएंगे. इवन यू विल हैव मोर इंफॉर्मेशन अदर देन दिस. दिस वाज ए मच सिंपलर मॉडल. Question is, what is the meaning of postulates? His question was, postulate means he don't have the derivation. ठीक है ना? From where these three whatever statements he was making, from where these statements are coming, he is not telling us, but he is postulating that this type of thing is there. ठीक है ना? He is not telling us how I get these postulates, how I get these ideas. He is just giving us these ideas. But cause how he find out these ideas, he is not telling. Later on, people use these postulates to find out radius, energy levels, everything, velocity of the electron. But there is nothing like this from where these three postulates. Actually, this was a theoretical understanding. Okay, this was
Sir,
his
this is
idea.
assumption.
That's why this is called a
Assumption.
postulate. Assumption type. Assumption means, assumption is a different thing. A little bit. Assumption means when you are trying to develop a mathematical model. So you will start from some simple ideas. You will make your problem very simplified problem. So to make that simplification, you have to assume something. You are approximating on the, you are having some ideas. On the basis of this, you are approximating in such a way that your system is becoming easier to solve. They are assumptions. Okay? And later on, these assumptions may be correct or they may be wrong. But here, he is saying that, okay, this type of thing is there. But he's not telling us how he get these ideas. That is was his insight. his understanding of physics. ठीक है? So many times when you are studying something, many things you can understand from your inside. So that understanding, inherent understanding, ठीक है, on that basis he gave these ideas and they are called as postulates. So कोई इनका mathematical और exact background नहीं है. Whatever understanding he is having at that time, on the basis of that he gave these three statements and that's why they are called as postulates. और इसीलिए बेटा इन्हें क्या बोलते हो आप? Postulates बोलते हो. Is it clear what I am saying, बेटा?
Yes, sir, it's clear now.
So where I was, कहाँ गया मेरा? Where is that slide? I lost. So basically, I was saying that three postulates were given. So first postulate was very simple. First postulate was very simple, that classical equation of motion is valid for this atomic system made up of nuclei and the electron. For the motion of the electron, you can apply this classical equation of motion. But this electron, it can orbit only in certain energy level. This atom can have only certain levels. And these levels, they are called as energy levels. आप क्या बोलते हो? Energy levels, they are having certain energies. So they are specified by energies. So this was the first postulate. This was first postulate. Second postulate. ठीक है? What second postulate was? Please write. When these electrons are revolving in certain orbits, when these electrons are revolving in these discrete or certain orbits, when these electrons are revolving in these certain or discrete or quantized orbits, comma, the motion of electron is radiationless. ठीक है? So he's saying motion of electron.
Sir, can you repeat again?
लिखो बेटा, ऐसे लिख लो, the motion of electron, और जब same sentence बोलना है, when electron is revolving in these, when electron is revolving in these discrete or quantized orbits, comma, the motion of electron is radiationless. Is radiationless. Is radiationless. ठीक है? तो देखो बेटा, what is this was a big statement, very important statement, because this is electron, charged particle, and when a charged particle is undergoing circular orbit, its motion is accelerated. Why it was so important? When electron is revolving in these certain orbits, ठीक है, its motion is circular, and so automatically this motion of electron is an accelerated motion. And when a charged particle is undergoing accelerated motion, it will emit radiation. That emits radiation. An accelerated charged particle emits radiation. But here, what is saying that motion of the electron is radiationless. So this was a great idea at that time. Later on, even he explained why he was saying like this. He was saying that if electron is revolving in this orbit. Yes, बेटा,
उसको
please.
वेव फंक्शन सर वो स्टेशनरी वेव हो जाता है ना,
ये स्टेशनरी वेव. Yes, बेटा.
इसलिए रेडिएशन नहीं इमिट करता है.
Yes, beta. So actually what he was saying, he was using quantum ideas when this electron is revolving in this circular orbit. ठीक है ना? It is exhibiting a wave character. This is exhibiting a wave character. ठीक है? It is
That
represented
field
by a,
वाला
यस
सर
बेटा,
पहले वाला स्लाइड थोड़ा दिखा दीजिए ना, मैं स्क्रीनशॉट लेना है थोड़ा एक बार।
मैं लास्ट में दिखा दूंगा बेटा, सारी स्लाइड्स दिखा दूंगा
ओके।
आपको, ठीक है ना?
ओके सर, थैंक यू सर।
वेलकम बेटा. So basically, when this electron is revolving in this circular orbit, this this electron is exhibiting wave character. A matter wave is associated with this. So when a matter wave is associated with this, then try to understand. So during the motion of this electron here, this type of stationary wave is formed. ठीक है ना? So this type of stationary wave is formed by the matter wave when this electron is revolving in this orbit. So he's not treating this electron as a particle. He's saying that it is exhibiting. Why it is not emitting radiation? Because it is exhibiting the wave character, and this wave character is such that only those certain orbits are possible where this type of complete structure is formed, where this type of stationary wave is formed. Only those certain orbits are possible, only those certain. So basically he was saying that 2 pi rn
n
r
lambda.
is equal to n lambda. He was saying this when he was not he was not saying just predicting, not like this. He was saying that only certain energy orbits are possible. Which orbits are possible? Those orbits in which when electron is revolving, it is not emitting radiation. Next question was why electron is not emitting radiation? Because this moving particle, ठीक है ना, it is exhibiting wave character, and that wave character is forming a stationary structure. And due to the formation of this stationary structure, it is unable, it is not radiating. It's not radiating. So one part of his second postulate was this, that when these electrons are revolving in certain or quantized orbit around the nuclei, the motion of the electron is radiationless. इसी में next in the second postulate, please write in the next line. However, इसी का second part. However, when electron jumps when electron jumps from one energy level to another energy level. However, when electron jumps from one energy level to another energy level, it either emits a photon, it either emits a photon or absorb the photon. Absorb a photon, और ब्रैकेट में लिखो रेडिएशन. So he's talking two things. On one side, he's saying when electron is revolving in this orbit, its motion is radiationless. But second, at the same time, is using that when this electron jumps from high energy level, this is high energy level, this is lower energy level. When this electron jumps from here to here, it is emitting radiation or photon. Or another, this is, you can say, this is EI and this is EF. ठीक है? So this EI minus EF, this will be H nu. High energy level and lower energy level. Or you can write EI EF के बजाय you can write E1 E2 if you want. You can write E1 and E2. So this time this H nu will be E2 minus E1. This will be H nu. H nu. Or if an electron is in the lower energy state, suppose in E1, then it will it can absorb a photon, H nu, whose energy is equal to E2 minus E1. And by absorbing this photon, this electron can jump here to the excited state E2. Okay? So this motion of the electron is radiationless when it is undergoing circular orbit. But when this electron is jumping from higher state to lower state, it is it is emitting radiation, and it is absorbing photon when electron is jumping from lower energy state to higher energy state. So this was the second postulate that was given by Bohr beta. So today I am going to stop here. Okay, in the next class I will continue from here. Okay, thank you very much, beta.
Thank you, sir.
Welcome,
Thank you,
beta.
sir.
Welcome, beta.
Sir.
सर पहले वाला स्लाइड थोड़ा दिखा
Oh,
दीजिए
yes, beta, please. I'm भूल गया था. I'm showing you from the first one.
Sir,
Yes, beta.
sir, all of the board's postulates were purely based on theories and assumptions, or there were any experiment explaining these before
No,
he gave the postulate?
no, there were not the experiments, but his understanding. For example, he's having his own logic around these postulate, but no mathematical basis or that type of theoretical basis was not there. So he was mixing two things, and he was mixing these two type of theories, classical and quantum theory, in a very accurate way, and he got very accurate result for one electron system. So that was difficult. Okay. So basically, understanding something and give postulate, that's okay. But when two different type of ideas are coming together and they are providing you the correct result, that was a big thing. तो एग्जैक्ट एक्सपेरिमेंटल कुछ नहीं था बेटा ऐसा, बट वॉट एवर ideas were there, on that basis he developed this model. At that time quantum mechanics was also in the developing state, so he used those ideas also. So this was the first one beta. Second one, third, this is next. ये नहीं है बेटा कुछ भी. This one, six, 7. थोड़ा सा मुझे लग रहा है ऑर्डर चेंज हो गया बेटा इसमें कुछ. एंड लास्ट वन, कुछ एक स्लाइड कुछ मुझसे कहीं शायद डिलीट हो गई, where I have started this Bohr model. So I will again continue from the Bohr's postulate, and then we will develop all the formulas. ठीक है ना? All the formulas for these energy levels. What will the velocity of the electron in different orbits when it is revolving? What will the radius of these orbits? When electron is revolving, then what will be its orbital frequencies? So all these aspects we are going to find out in the next class. चलिए, thank you very much, beta.
Thank you, sir.
Welcome, beta.
Thank you, sir.
Welcome, beta.
गुड नाइट सर